Okay, so I'm going to show you how to work through example 2 here of a solution. Our goal is to graph or to sketch f of x equals sine x minus 180 degrees, subtract 4. Well, what you see on my page here is I've actually graphed the function f of x equals sine x. Now the reason why I want you to do that is so that we can pick out some key points, which you probably already know. So f of x equals sine x. On your page in front of you, I want you to graph what I've graphed here. So if you need to pause the video, go ahead. Once you have the graph set up, I want you to show me a small table of values that I've shown here. These are key points that belong to the graph of sine x. Now they're going to be different for cos x, but quickly here let's just figure out x is 0, then we know sine is 0. 90, 180 will be 0 again. At 270 we have negative 1, and 360 we have 0. So these 5 key points correspond to these red dots that we see along the graph of sine. I've just shown one cycle. Okay, this will continue as I've shown with the green dotted lines. So I'm going to go to a new page here, and I've recopied that table of values. So it's the same table of values you should have. My goal is to graph, let me change to red. My goal is to sketch that function there and basically describe the period, the amplitude, the phase shift, etc. First of all, look at that equation and write down what has happened to the graph. Sine x minus 180. Well, because there's minus 180, that means that there is a horizontal shift. We also call that the phase shift. 180 degrees to the right. Remember that it's always the opposite sign. There's also a vertical shift. Down by 4. So we're going to take these translations, and we're going to change these key points on our original graph and turn them into something a little bit different. So let's go to a new slide. You don't have to recopy your table of values, but I'm going to quickly jot them down. We have x, we have sine x. Let's look at the first key point. So this is our old graph, and I want the new graph here. So we're going to have x, and we can write this as the sine of x minus 180 minus 4. So if our original point here existed as 0, 0, we saw in the last slide that there was a horizontal shift to the right by 180 degrees. So we're going to take 180 and add it to 0, our original point. So 0 plus 180, because it's a shift to the right. That's why I'm adding 180. Our x value here is going to turn into 180 degrees. We also said that there was a shift down by 4 units. So that means we're going to take the 0 that you see at that column and we're going to subtract 4. 0 subtract 4 is negative 4. Now let's work with our other point. The next point is going to be 90 and 1. Again, that was from the parent function, the graph of sine x. Let's transform them. 90 plus 180. We get 270 degrees. Now we have 1. Again, we have to subtract 4. So we're going to end up with negative 3. And you're going to keep working with this pattern. Next one is going to be 180. We're back at 0. 180 plus 180. Again, this is going to be 360. 0 minus 4 is negative 4. This is going to be 270 and negative 1. 270 plus 180. Fill this out. You should be writing on your page as I'm doing this as well. Negative 1 subtract 4 is negative 5. And 360, finally, 360 plus 180 is 540, and this should be a 0, 0 subtract 4 is negative 4. So your job right now is to, on your graph paper, draw me a new graph by plotting these points that you have in your new table of values. So take these points, 180 and negative 4, 270, negative 3, etc., etc. Graph each of those points and see what you get. Once you graph the new function, you can answer the questions: the period, the amplitude, the phase shift, the vertical shift, equation of the axis, the domain, and the range. What I'll do is I'll post a final picture of what your graph should look like. I want you to try it on your own and the answers to the questions in the chart.